fact, well, it looks like, and I'm not sure about this, but it looks like we have probably made it through the first week of flipped physics. This is unit P19. This is all about reflection, and we're going to be covering concave mirrors today, and we'll also be talking about convex mirrors. All right. Concave mirrors are mirrors that have reflective surfaces that curve towards the observer. The inside surface of a spoon is a concave mirror, and concave mirrors can produce real images in front of the mirror. Let's look at these things. With a concave mirror, the center part is caved in. It is pushed away from the observer. The edges are closer to the observer than the center is. Because of this, when light strikes the surface, it's not striking a nice smooth surface. It is striking a curved surface, and as a result, at every point on that surface, the normal is going to be pointing in a different direction. All right, the concave surface means that the light, as it comes in, if it's going to be a parallel beam of light, it's going to be bounced off and it's going to be focused, it's going to be reflected, and it's going to tend to meet at one particular spot, and that's called the focus. As it turns out, if we've got a spherical mirror, that the distance, if we have it, a particular radius of that sphere, that spherical radius is exactly twice the focal length. In other words, if we have a point halfway between the mirror and the center of curvature, that point there is going to be called the focal point. And the focal point is literally that. If incoming light, parallel light is coming in, it's all going to be focused at that one particular spot. This is a good thing because we can use this for a variety of situations. For example, if I go and put a light bulb right at the center of at the focus, and I turn it on, light's going to be scattered in all different directions. But the light that hits the mirror, instead of continuing on, it's going to bounce off, and it's going to bounce off parallel. And it's all going to go in that direction there. So if I build this thing properly, I can have half of the light from this particular bulb going in a straight line that way. And we do this all the time. This is the basis behind a flashlight or the headlamps on a car, is that the light that would be going back that way towards you if you're holding a flashlight, or the car if it's a headlamp, that's now all being pushed in one direction. That's all reflected in one direction, and that's how we get that intense spotlight effect from the flashlight or from the headlamp on the car. So this is the use of a parabolic or a spherical reflector, so that all of the energy is pushed in one direction. The flip side is this: if I have all this energy coming in and focused at one particular spot, a very, very weak signal can be made a lot stronger. So if I'm picking up, say, a radio broadcast from a long distance away, I have a large antenna, and we're talking about, for the satellite dishes that big. If we're picking up very weak signals from deep in outer space, we can have 85-foot, 210-foot, 400-foot radio telescopes picking up these signals and amplifying them, so that signals that are coming in from way out at the edge of the solar system can be amplified, because we're picking them up using these very large dish antennas and focusing all that energy at one particular tiny spot, and then picking up the signal. Some interesting aspects of the concave lens or the concave mirror is the fact that we use these quite a bit in our homes. If you've got a shaving mirror or a makeup mirror, these magnify. You're close to it, and you look in the mirror, and everything is enlarged. That's why it's enlarged, because it's a concave mirror. All right, we use these things for magnifying mirrors and for a whole variety of other things. All right. There's a flip side of this. The convex mirror. And the convex mirrors are mirrors that have reflective surfaces that curve away from the observer. The outside surface of a spoon is a convex mirror. Convex mirrors produce virtual images behind the mirror that seem to be small and far away. Concave mirrors produce what are called real images. We can take the light and we can focus it at one particular spot. If I was to go and take a concave mirror out in the sun and focus it at one particular spot, I could go and set things on fire. It's not a very practical way of doing it. If you're stuck out in the woods, you can carry around this giant mirror, but it'd probably be better to carry around a giant radio to get you out of there, to call for people, but it can be done. On Mythbusters, for example, they showed that you could actually use the bottom of a Coke can, a can of Coke, and use that as a reflector to go and light kindling on fire, and in an emergency you could actually use it to start a fire. That's a real image. It's actually, the light is concentrated at one particular spot and you can project it onto things. That's a concave mirror. Convex mirrors, on the other hand, they curve away from the observer. The center point is closer to you than the edges. It's the opposite of a concave mirror, and everything that we see with a concave mirror, the opposite will be true with a convex mirror. Whereas a concave mirror we can use as a magnifying mirror, the convex mirror makes everything small. Okay, it's a smallifying mirror if you want. It doesn't embiggen things, it smallifies them. It makes them smaller, and they appear to be farther away and smaller, and that's one of the reasons why, if you look on the passenger side of a car, the passenger side window will quite often say, the objects in the mirror are closer than they appear to be, because you've got a wider field of view. You can see a larger expanse, but at a price, and that price is their perspective is distorted. The objects are smaller, they look smaller and farther away than they really are. These are the convex mirrors produce virtual images. The light seems to be coming from behind the mirror, but there is nothing behind the mirror. It is all a reflection from in front of the mirror. We can't project the light onto something from a convex mirror because it's scattering out. It's not focusing, it's scattering out. So everything that we know to be true for a concave mirror is going to be opposite for a convex mirror. Okay, they are natural complements to one another. We use the convex mirrors for a whole variety of things. We, as I said, use it for the passenger side of the car. The mirrors inside of stores. Okay, you go down to the Quickie Mart and you look up. There's these concave mirrors, or convex mirrors rather, and that's so that the clerks can have a wider field of view than just a plain mirror. Okay, they don't necessarily need to see in fine detail what's going on. They need to know where people are and what they're doing. They use them in inside of cameras. They have them inside there so that you get a wider field of view when you take a picture. Whole variety of different applications. Again, concave, convex, natural complements of one another. When we talk about doing ray diagrams, we'll go into more detail about what happens with them. All right. Questions, comments, difficulties, email me, or better yet, post it on the forum. We'll see you tomorrow in class. We'll go ahead and have our quiz and then go on and start doing ray diagrams for the convex and concave mirrors. Until then, I will see you later.